Is that it? Are we running? I feel like we need like some kind of theme music. I mean, this is after all the second one. So da da da, Rough Science Show, da da da. Here we go, da da da. Hello, hello, hello. Welcome. Thank you so much for tuning in. I really appreciate this. I know this is kind of trying times at the moment. Here in Melbourne, we've got places being locked down. And so if you are looking from or watching this from one of these lockdown places, it's okay. We're all in this together. So if you need anything, reach out, say hi, and so on. But today, welcome to Rough Science Workshop. My name's Sean, and like I usually like to do at the start of any kind of workshop, any kind of thing about science, I like to ask you, what is science? What is it? What is science? When I say the word science, what pops into your head? So for me, science is simply this. Science is a way to answer questions. Just that. Science is a way to answer questions. And the question that we're going to be looking at today is we're going to be looking at ice and we're going to be looking at salt. Now, if you know you've got some at home right now, run to the freezer, grab yourself a bowl full of ice. If you've got some salt, go get the salt shaker and bring it down. We are going to use some food coloring. If you don't have food coloring, that's okay. I'm just going to do something with this which makes playing with salt a little bit more interesting, but it's not critical. So if you've only got ice and salt, that's fine. Go for those. Okay, let's begin. Now, what I want to do is think about ice, but in particular, thinking about this thing here. This is a thermometer. It just so happens it's got two scales on it. It's got the Celsius on one side and it's got the Fahrenheit on the other side. So Fahrenheit, named after a guy called Fahrenheit, and the Celsius scale, named after, well, actually, there's a good question. There's homework for you. Find out where the name Celsius came from. But here's the important thing. 0 for both scales are in different places. For the Fahrenheit scale, it's down here. For the Celsius scale, it's up here. So 0 Celsius is about 32 degrees Fahrenheit. And 0 Fahrenheit is about 18 or so Celsius. So why the difference? Well, the reason for that is to do, if we think about the Celsius scale, the way that that scale was sorted out, the way that they figured out where 0 would be, was basing it on water. So when they took water and froze it, the moment it hit 0 degrees Celsius was the moment that the water went from being liquid to being a solid. So the moment at which water turned to ice, and that would be 0. 100, which isn't on this scale, is the moment when water would start to boil and turn from being a liquid to being a vapor. So the boiling point of water would be 100 degrees Fahrenheit, 100 degrees Celsius. But interesting things happen when the water isn't pure. So at the moment, this is, I would imagine, fairly pure water. Wouldn't be 100% pure, but it's pretty pure, which means that it's solid at 0 degrees Celsius. But we can start to do things to it if we add salt. So what I want to do, I'm going to get some ice and I'm going to get some salt. But before we do that, I want to try something out with some salt because we've got some nice white salt here, but I want to add a few colors to my salt. And so one way that you can do it is to get a little bit of food coloring, just a tiny bit, like half a capful. And if you've got a lunch bag, you can put this into the lunch bag like that. And then into the lunch bag, put in a couple of scoops of salt. There we go. And if we zip it up, and then start throwing it around. Now you don't want a lot of food dye because you don't want all the salt just dissolving in the food dye. You just want a little bit so that the food dye ends up being sprinkled in amongst it. Like that. And there we go. We've got blue ice. Let's go for some other colours. I've got some red here as well. Let's get a fresh bag so that we don't end up with too much colour mixing. Or, if you want to, a little bit of blue, a little bit of red, you might get some purple ice. Okay, so a little bit of red into the bag like that. And then zipping it up. Making sure you zip it up. Let me tell you about the time that I flipped this around and it came undone and went all over the couch. Food dye and couches don't mix. Actually, food dye and couches do mix. They mix really, really well. Don't try that out at home. Try it at your friend's place. All right, there we are, some red salt. And finally, a little bit of green food coloring, RGB. And a little bit of salt. Back up a sec. Did I just call the salt ice earlier? The team here are nodding vigorously. Yeah, that's what I meant to say. I meant to say salt. This is live. Trust me, you know. On live TV, John Howard had a set of shoes thrown at him. Fun times. Look that up on YouTube later. I would also like to point out that Rough Science Workshop is apolitical. Okay, there we go. Some nice coloured salt that we can use for the next bit. So the next bit, all we're doing is doing something that scientists do all the time. When scientists do an experiment, one of the key things that they do is it's not sort of like putting things together to see if it explodes, to see if it makes salt. We're not going to put Mentos and Diet Coke together. Don't ask me to do Mentos and Diet Coke. It's not an experiment. And I am going to be very, very clear about that one. No. What we're going to do is we're just simply going to observe and see what happens next. So let's get some ice and put them down here. And let's switch to a camera where we can actually see them a little bit closer. And so here's our ice. And we'll just start scooping some of this salt on top and just watch and see what happens. Now, always when you do an experiment like this, it's always good to have control. And our control in this case is going to be some ice that sits over here. I'm not going to do anything to that. So we've got some ice there that's got some white salt on it. Let's go for some different colors. Let's go for some green salt just over here. There we go. How about some blue salt? And this one here, we'll put on some red salt. And if you've got enough ice, maybe you can do a few different things. Let's try mixing a few colors. Let's try some green and some blue. And maybe over here some red and some blue. Like that. And if you get down close to it and have a close look and see what's happening to the salt. The salt's getting wet, starting to dissolve. But also something's happening to the ice. So if you have a look at the control ice over here, our control ice is still pretty smooth and so on, but our ice here is starting to become pitted. there's little holes being drilled into it where the salt is currently sitting. If I brush this salt off here, you might be able to see it. It's starting to drill into the ice there. We've got the same thing going on for the blue and the red and some of these other ones here. And these ones here, the food colouring is starting to mix. It's starting to get colours. Now here's the thing. It's very hard for me to show you just like this to see exactly what's going on. You might be able to see this a little easier at home if you had your own ice and your own salt. But I'll tell you what we're going to try out here now. We're going to see if we can have a really close look at what's going on underneath. And for that, what I need is a microscope. What I have is one of these. It's called a USB microscope. So if you imagine what a microscope normally is and how it works, a microscope is basically a couple of lenses. And we put our eye up to one, and there's another lens down the bottom, and then we put things underneath it so that we can actually see what's going on at a small level. The light is bent through the lenses, and so we can see at a micro level. This is exactly the same thing. We've got a lens at this end, but instead of a place to put our eye, there's a little camera. So it's actually hooked in to my computer over here. So in a moment, we're going to switch over, and so we can see what's going on. What I'm going to do though, before we switch over, is I'm going to get our ice set up. I've got some ice here that is going to be normal, and some ice here that I'm going to put a little bit of salt on, and we can have a close look and see what's going on. So let's turn on the microscope and see what we can see. So the microscope, well, it's always good to test out the microscope on something to make sure it's actually working. So let's stick it on, here's my thumb. A nice close-up look at my thumb here. There, you can see the ridges of my thumbprint. You can see the white bits of dead skin in between the thumbprint. I clearly need to use more moisturizer. If I go up this way, you'll see, oh yeah, I was playing with some of the food dye before, and you can see some of the food coloring has sat in the cracks of my thumbprint there. And if you keep moving around, actually there's a cool thing that's happening right there in the middle, in the center of the screen. You might see a little round thing. See if I can get closer to it. That is a sweat gland. You can see it's shiny. There's another couple more on the screen up there as well. There's sweat glands on our skin which put out sweat, and you can see there it is on my thumb there, popping out a little bit of wet sweat there. Microscopes are fun. Let's try putting it somewhere else. What about here? Guess where it is? That's my head. So you can see there's my hair. There's probably a little bit of dandruff. Oh yeah, right there. Bit of dandruff, top of the screen. And my hair is mostly brown, except for the bits that are going grey. All right. What about this bit? That's right. It's my tongue. My tongue, under the microscope, you can see all sorts of things. It's there's some taste buds. So you can see there's lots of cool stuff to see under the microscope. I'm just trying to remember the last time I used this. Tastes ever so vaguely like vinegar. Okay, so microscope is working. So let's have a look at our salt and ice and see what's going on. So let's have a close look at the ice first before we actually put some stuff on it. Okay, close up look at the ice. You can see the camera has got a little halo of lights, and you can see those there as those lights there. That's the lights that are actually sitting around the lens, and you can see it reflected off the liquid in there. Let's go over to the ice there and have a close look. And our ice, if you imagine, this is water which has turned solid. Okay, I'm just simply going to take some salt here and sprinkle it into the pitcher, and we'll see what happens. That's the salt there. It's starting to dissolve. But hang on, the ice itself is solid, right? How does the salt actually dissolve? And as it keeps going, you can see here it's dissolving, and the ice that's underneath it is starting to melt. But nothing's happening to the temperature around us at the moment. The temperature of the room that we're in is about 22 degrees. The ice itself, I imagine, would be quite cold. But if we go over to this part of the ice, you can see it's just the way that it was. But the part that we've dropped the salt onto, we've got all this pitted look. I tell you what, let's try it again. We'll try it to this piece of ice over here, but this time I'll use some of the colors and we can see what happens there. So our colored salt, the color is actually just sitting on the outside of the salt, and so when it hits the water there, it starts to mix with water and disappear. But the salt is still doing the same thing that we observed before. We're getting these pits being made all over the surface of the ice. So why is the ice being melted by the salt? What is it about the salt that's causing the ice to melt? Well, let's come back to camera one and have a think about this. Our ice, like I said, it's solid at 0 degrees Celsius. But an interesting thing happens when you get pure water and you start to mix salt into it. The salt reduces the temperature at which the water turns to a solid. So instead of being a solid at 0 degrees, when we start adding some when we start adding some salt, that salt dissolves in a little bit of that water that's already liquid on the surface, and it changes the ability for that water to change into a solid. Instead of being at 0 degrees, it's now lower. So it might be at -6 degrees, or it might be at -16 degrees, depending on the concentration of the salty water. So the salty water now doesn't turn to ice at 0 degrees. It turns to ice at a lower temperature. This piece of ice in my hand is very, very cold. I can tell you it's very, very cold because I'm currently holding on to it and it hurts. Ow. But it's not at 0 degrees. It's at a temperature that's lower than 0 degrees. If we put a thermometer onto this, we would see that the temperature is lower than 0 degrees. But by putting the salt onto it, we're changing the ability for that water to remain as a solid. And so instead of being a solid at 0 degrees, its melting point is changing. So if it turns to ice now at -6 degrees Celsius or -10 degrees Celsius, that might be a temperature that this ice isn't at, and it's starting to melt. So we've got these bits of ice that are here that are starting to melt because we've got the salt on top of them. Our ice here, our control piece, is still doing pretty okay. It's just sitting there normally, whereas these ones here have huge puddles of water sitting around them. Let's have a closer look, and you'll see that there is huge puddles of water around these bits that have got salt sprinkling all over them. So our control is over here. Not very much water around it, whereas these ones are melting quite a bit, and that's because the salt is changing the freezing point of the ice so that it starts to melt. This is useful for us. Well, maybe not so much for here in Australia, but if you go to a place where you get a lot of icy, frosty roads, particularly if you went to, say, England or Scotland, you might see buckets on the side of the road that say grit. And grit is basically a mixture of salt, rock salt, plus a few stones, and they throw this sandy, stony mixture out onto the roads when you get frozen nights. So when you've got a lot of snow, it becomes very slippery for cars to be able to drive around on. And so using this salt, you can actually start to melt the ice that's on the road, even though the current temperature outside might be 0 degrees Celsius or below. So there you go. Salt and ice and melting stuff. Let's stand up here and have a stretch. That was today's Rough Science Workshop. Now, for the rest of this week, we are going to be doing a Rough Science Workshop in the afternoon, probably around about 2 or 2:30, and it's going to be a different experiment on each day. So be sure, if you'd like to come along, come and join us. If you've got any questions, be sure to pop them into the chat. We'll see if we can get to them. But if we can't, then we might try to reply to some questions on social media. So if you're on Twitter or on Facebook, be sure to check out the Rough Science Workshop pages from there. If you have any questions about any of these or want to know when the next one is, go to roughscience.net and there's information there under workshop. You can find out more. Thank you so much for coming along. I know we're in some weird times at the moment, but stay happy, stay safe, and remember, science is a way to answer questions. And we'll talk to you later. And here's where we cue in some outro music. Do do do. It's the outro music. Do do do. The outro music dance. Do do do. The